Welcome to this deep dive where we really try and, get under the skin of a fascinating subject.
Huh.
Today, we're heading back, way back to the late Cretaceous.
Yeah, a favorite period.
We're going to unpack the story of, a pretty small dinosaur called Ajkaceratops.
It's a great one to discuss.
We've gathered various scientific publications, bits of info derived from them to piece together its surprisingly twisty tale.
It really is twisty. The story keeps changing.
So our mission, basically understand what the science tells us now about this dinosaur.
Right. And the debates around it, where does it fit?
Exactly. And, what kind of world did it actually live in?
Precisely. It's a brilliant snapshot of paleontology in action. Discovery, then refinement.
How science actually works sometimes.
Yeah, Ajkaceratops really shows how our picture of these extinct animals can change. Sometimes, like dramatically.
As new stuff comes to light.
Exactly. New evidence, better ways of looking at it. It's not just about one little dino. No.
It ripples outwards.
It can potentially shake up our understanding of whole branches of the dinosaur family tree. Even with fossils we thought we knew.
Okay, let's dig in then. Let's meet Ajkaceratops. First off, how do you say that?
Ah, yes. It's Ajkaceratops.
Ajkaceratops. Got it. So it was first described back in 2010.
That's right. And it lived during the Santonian stage, late Cretaceous.
Which is roughly...
Oh, about 86 to 84 million years ago, give or take.
And you have to picture Europe then, not like today at all.
Not at all. The fossils were found in Ajka, in Hungary.
Okay.
Which back then was part of what we call the Western Tethyan Archipelago.
So islands. Lots of islands instead of a solid continent.
You've got it. A very different world map.
And the species name, Acosma?
That honors Carolee Cosma. A little tribute there.
Nice. Okay, so what do we actually have? What are the fossils?
Well, the main evidence, the original specimen, is called the holotype. MTM V2009.192.1.
Right.
It's kept at the Hungarian Natural History Museum in Budapest. But it's important to know it's quite limited.
Not a full skeleton, then?
Oh, no. Far from it. We're talking fragmentary skull remains.
Like what parts?
Mainly a snout section, with what they first thought was a rostral bone.
Okay, the rostral bone. That's the beak thing. The special bone on ceratopsians.
Exactly. That unique bone at the tip of the upper jaw defines the group, really.
What else?
We also have fused premaxillae. Those are bones right at the front of the upper jaw. And some fragments of the maxillae, the main upper jaw bones.
It's just bits and pieces, sounds like.
Pretty much. And based on those bits, the initial estimate was, well, pretty small. About 1 meter long.
So like 3.5 feet. Tiny, relatively speaking.
Yeah, for a dinosaur, definitely on the small side.
Is that it? Just the one specimen?
Well, there's also mention of some other bits. 4 smaller predentary bones.
Predentary, that's the lower jaw.
It's the unpaired bone at the very front of the lower jaw in Ornithischian dinosaurs. So yeah, lower jaw.
Different individuals.
They're cataloged separately, MTM V2009.193.1 through .196.1. They're thought to belong to other Ajkaceratops.
And they're smaller.
Yeah, which might suggest they came from younger animals, perhaps. Juveniles, maybe.
Okay. Now this is where the story gets interesting, right? The classification.
Absolutely, because when it was described in 2010, the conclusion was, well, quite specific.
They linked it to Asia.
They did. They proposed it was a ceratopsian, closely related to Bagaceratops.
Which is from Mongolia, East Asia somewhere.
Exactly. A protoceratopsid from East Asia.
So how would a Hungarian dinosaur be related to an Asian one?
Well, the idea put forward was based on perceived similarities in the skull fragments. And it led to this hypothesis of migration. Island hopping, essentially.
Wow, across the Tethys Ocean Islands.
That was the proposed route, from East Asia to what is now Europe. It's a cool idea. Shows how dinos might have dispersed.
So in that original picture, where did it sit within the ceratopsians?
It was seen as fairly primitive. More basal is the term we use.
Meaning like an earlier branch?
Yeah, branched off earlier than things like Unearthed or the really derived Ceratopsidae.
The ones with the big horns and frills like Triceratops?
Exactly. Ajkaceratops was seen as being much earlier on that lineage.
But there's always a but in paleontology, isn't there?
Huh. Often, yes. And this is a prime example. Further research, closer looks, things started to seem less certain.
About it being a ceratopsian at all.
Pretty much.
Yeah.
The fragmentary nature of the fossils really comes into play here. Makes interpretation tricky.
So what was the issue? That rostral bone again?
That became a major point of contention, yes. More recent studies highlighted some key differences.
Compared to other ceratopsians.
Right. For instance, the cross-section of the bone in Ajkaceratops seems kind of subcircular.
Not typical.
Not really. And the texture is described as pitted, not grooved like you'd usually expect.
Okay.
And it also seems to lack those sharp lateral edges, the slicing edges, that ceratopsian rostrals often have.
Anything else?
Maybe the biggest thing was how it fused to the premaxilla.
How so?
In Ajkaceratops, this proposed rostral bone seems really solidly fused to the premaxilla.
And that's weird.
It is for an early ceratopsian. You sometimes see fusion in, like, very old individuals of the really advanced ceratopsids,
Yeah.
but not usually in basal forms.
So that early solid fusion just didn't fit the picture of a primitive ceratopsian.
Exactly. It raised serious doubts, like, maybe this bone isn't actually a rostral bone at all.
Whoa. But if it doesn't have a rostral bone,
Then it's probably not a ceratopsian, right? That bone is considered a key defining feature, a synapomorphy of the whole group.
so if it's missing, the classification falls apart.
It becomes very, very shaky.
Yeah, so what's the alternative if it's not a rostral?
The alternative hypothesis is that the hooked beak structure we see, it might just be a really modified, elaborated premaxilla.
The front jawbone itself grew into a beak shape.
Possibly.
Yeah.
And if that's the case, then the similarities they initially saw with Ajkaceratops might just be superficial.
Or convergent evolution, like evolving similar shapes for similar reasons, but not being closely related.
Precisely. Similar feeding habits or environmental pressures could lead to similar shapes independently.
So where does that leave poor Ajkaceratops? It's like it lost its family.
Huh. Yeah, it's become a bit of a paleontological enigma. Often now it's just listed as an Ornithischian.
The broader bird-hipped group.
Right, an Ornithischian of uncertain affinities, meaning we know it's in that big group, but we're really not sure where it fits within that group.
Uncertain affinities, that sounds frustrating.
It means more work is needed, but the story actually takes another turn.
Oh, there's more recent evidence.
Potentially. There was a redescription of the skull of Johalosaurus.
Okay, what's that?
It's an early Cretaceous Neornithischian from China, a small plant eater.
And how does that connect?
Well, a phylogenetic analysis, that's where they use software to figure out evolutionary relationships.
Right.
An analysis by Bertozzo and colleagues, published recently, like 2025, it threw a new possibility into the mix.
What did it find?
Their results suggested Ajkaceratops might be a sister taxon to another dinosaur called Changmiania.
Sister taxon means closest relative.
Basically, yeah, each other's closest known relative in that specific analysis.
And what does that imply for Ajkaceratops's identity?
Well, if that relationship holds up under further scrutiny, it would place Ajkaceratops as a basal ornithopod.
Ornithopod, that's the group with iguanodon and the duck-billed hadrosaurs, right?
Exactly, a completely different major branch of the Ornithischian tree compared to ceratopsians.
Wow. So from maybe horned dinosaur relative to maybe duckbill relative, that is a huge shift.
It really is. And it shows how re-examining other fossils, like Johalosaurus, and using new analytical methods can totally reshape our understanding. It's not just finding new bones, sometimes it's looking at old ones differently.
That's fascinating. So with this potential new identity, let's think about its world again. The Székely Formation in Hungary, what was that place like 85 million years ago?
Right. So the rocks themselves, geologists look at the layers, the types of sediment.
Clues in the stone.
Exactly. We see things like variegated clays, silt with sandy layers, sandstone beds. It points towards an environment with floodplains and river channels. So rivers, streams, areas that flooded periodically. Reasonably wet.
Okay, a river delta or floodplain system on these islands?
Something like that, yeah. And when you look at the other fossils found alongside Ajkaceratops,
So you get a picture of the neighbors.
you do. And there's a diverse neighborhood during that Santonian stage there.
Other dinosaurs?
Oh, yes. There was Mochlodon, another type of ornithischian, actually a rhabdodontid.
Okay.
Also Nodosauridae ankylosaurs. Those are the armored guys, but the ones without the big tail clubs.
Gotcha. Plant eaters mostly.
These ones were, yeah. But there are also other non-avian theropods around, meat eaters of various sizes.
And birds?
Yep, finds of enantiornithine birds. That's an early, now extinct group of birds that were very common in the Cretaceous.
So quite a few dinosaurs and early birds. What else shared the island?
It wasn't just dinos. The formation has also given us fossils of Unearthed crocodiles.
Ancestors of modern crocs.
Pretty much, yeah. Also as dark pterosaurs.
The huge flying reptiles, like giraffe size.
Some of them were enormous, yes. And also bothromitid turtles and even tide lizards.
So a really rich ecosystem. crocs in the water, pterosaurs overhead, lizards scurrying around, various dinos.
Yeah, definitely. A complex food web in this European archipelago setting.
Yeah.
Quite different from anywhere else at the time, likely fostering some unique evolutionary paths.
Okay, let's try and wrap this up. Summarize the Ajkaceratops journey.
Sure, so it starts with a discovery in Hungary, described in 2010.
And initially flagged as a ceratopsian, a horned dinosaur relative,
Hmm.
with ties to Asia, island hopping.
Right, but then came the challenges. Questions about that key feature, the rostral bone,
Did it even have one? Its shape, texture, fusion, it all looked a
and
bit off.
which cast serious doubt on the ceratopsian identity, left it kind of floating as an ornithischian of uncertain affinities,
Until this more recent analysis, linking it potentially to Changmiania.
suggesting it might actually be a basal ornithopod, closer to the duckbill lineage. A total rethink.
And we also got a glimpse of its world, that late Cretaceous island floodplain in Hungary, full of diverse life.
Absolutely. The whole story really underscores how dynamic paleontology is. It's a self-correcting process.
What we think we know can definitely change.
Constantly. New finds, new analyses of old finds, new perspectives. It keeps evolving. Ajkaceratops is a perfect example of how much can shift, even from just a few fragments.
Which leads nicely into our final thought for you. Given this pretty major reevaluation of Ajkaceratops, I mean, going from one major group to potentially a completely different one,
Yeah.
it makes you wonder, doesn't it? What other long-held ideas about dinosaur evolution, maybe about how groups are related or where they lived and how they got there, what other assumptions might be overturned next?
That's a great question. What surprises are still buried waiting to be found?
Or waiting for a fresh look at fossils already sitting in museum drawers? How much more might our picture of the prehistoric world change?
It's exciting to think about.